Hi, hello. Let's see some problems based on Wavy Curve method, which is also called number line rule or method of intervals. So this method is used for solving algebraic inequalities, which have the form f of x by g of x, which is either can be less than 0 or greater than 0 or less than or equals to 0 or greater than or equals to 0. So there are certain things to be noted. The first point. So f of x by g of x changes, it can only change sign at its zeros of f of x and g of x. So we can use the roots. So we can use the roots of f of x and g of x. And second point, so draw the number line. Draw the number line and mark up the roots of f of x and g of x. Mark up all the roots we can take. Every root of f of x and g of x in an order. And third point, third step we can say, a wavy curve. A wavy curve is to be drawn. Curve is to be drawn from right to left. Starting from the rightmost root of the given expression from positive side. And then the next step, if the root is of single root, I mean the power is odd powers. If the root is single, we say it's a single root if it is a power is odd number. So odd power of any linear factors. The curve will intersect the number line, which means that it passes to the other side, intersects the number line. That means it changes from positive to negative or negative to positive. So it changes from positive side to negative side or negative side to positive side. And if the root is double, if that root is double, so that means even power, we can just consider even power. Then in such a case the curve remains located on the same side. Means if it is in the positive, it remains in the positive, or if it is in the negative, previously it will be remain in the same negative side, same side on the number line. Okay, let us apply all these rules in problems. Let's solve the problems. Now let us try to understand the concept with all different models. It starts with the linear factor 1. Say f of x is equal to x minus 3. First one. So it's only one linear factor and the power of x minus 3 is 1. Now it's a zeros. Zeros of f of x is only 3. Since for x minus 3 equals to 0 equation, so we have x is equal to 3. So let us mark it on the number line. Take a number line. Let's mark it 3 and start taking the curve, wavy curve from the right side of 3. Since we have only one factor, so this is 3 will be the rightmost factor, and start taking the curve from the right side, from the positive side. And since the power of x minus 3 is 1, it's a single root. Since it's a single root, the curve will changes from positive side to negative side at 3. We can observe that the curve is changing its a sign positive to negative, means from upper side to lower side, and it continues. So that we can just identify. So as per the requirement, suppose our curve is required f of x is less than 0, that is x minus 3 is less than 0. Then in such case we can give the answer. Where is negative region from the graph? So minus infinity to plus 3. So we can say x belongs to minus infinity comma 3. And if suppose here f of x is greater than 0, that is x minus 3 is greater than 0. So which implies we can just observe that it is a positive on from 3 to infinity. So we can say x belongs to 3 to infinity, or above 3 we can say. It's above 3. And if it is like f of x is less than or equals to 0, less than or equals to 0, that is x minus 3 is less than or equals to 0. So whereby we can give the solution. So from minus infinity to 3, including 3 also. So we can include 3. So up to 3. And if f of x is greater than or equals to 0, that is x minus 3 is greater than or equals to 0, then in such case the answer can be taken 3 comma infinity. 3 can be included. It's an open interval infinity. So this is how we can just find for a linear factor single. So easily you can just observe the things like if x minus x is greater than or equals to 3. So here x is greater than 3, here x is less than or equals to 3, here x is greater than or equals to 3, and here x is less than 3. So but your wavy curve method will help you in finding out this kind of solutions. Let's see another example. Consider second one. F of x is equal to x plus 5. The 0 of f of x can be taken minus 5. Since x plus 5 is equal to 0, we have x is equal to negative 5. So let us mark that on number line, negative 5. And now let's assume that f of x is less than 0. For f of x less than 0, that is x plus 5 is less than 0. So by using wavy curve method, start taking the curve from the right side of negative 5 from the positive side, and then at 5, negative 5, just we have the power is odd power, means 1. So we can change the number line, it intersects the number line, that is changing from positive side to negative side. So that we can just identify here for x plus 5 less than 0, so x must belongs to minus infinity to minus 5, so open interval. And if f of x is less than or equals to 0, that is x plus 5 is less than or equals to 0, so which implies that x belongs to negative minus infinity to negative 5, it's closed. So we can include minus 5 also. And for f of x is greater than 0, that is x plus 5 is greater than 0. So we can say here x must belongs to the positive side. Positive region is minus 5 to infinity. So we can say right here negative 5 to infinity. And if f of x is greater than or equals to 0, that is x plus 5 is greater than or equals to 0, which implies x belongs to minus 5 to infinity including negative 5. So this is how we can just find by Wavy Curve method. Let's see another kind of example. P of x is equal to x minus 3 upon x plus 2, which is in the form of f of x by g of x. So zeros of f of x is, let us find the zeros. Zeros of f of x is only 3 and zeros of g of x is minus 2. Since for x minus 3 is equal to 0, we have x is equal to 3, and since for x plus 2 is equal to 0, we have x is equal to negative 2. So let us mark these roots on the number line. Let's take number line. Positive 3 and negative 2, they are in an order, the number lines. So here minus infinity plus infinity. Now let us assume the first case. Your p of x is greater than 0, that is x minus 3 by x plus 2 is positive. So we need to start taking the curve from the rightmost root, that is root 3. From here you should take the curve from positive side to negative side, but before it is crossing you need to check the power of x minus 3. The power of x minus 3 is 1, which is odd, means single point. So the curve will change from positive to negative side and it reaches at the point minus 2. And then again we need to confirm the power of x plus 2 is odd or even. So for x plus 2 the power is again 1, it's an odd power, so it will changes from negative to positive. So before it is negative, from negative to positive it changes. Right, now we can observe that the positive region, we want the solution positive, so the positive region will be obtained for x belongs to minus infinity comma minus 2 union 3 to infinity. And for x minus 3 upon x plus 2 is greater than or equals to 0, where we can just consider while solving for greater than or equals to 0, the numerator can become 0 but the denominator must not be equal to 0. So we must not include my negative 2, even though you can include 3, but negative 2 should not be included to avoid the domain of the function. So the negative, so x belongs to minus infinity comma minus 2. So minus 2 must not be included, so it is always open interval union, and again 3 to infinity, so 3 can be included, so we can close this one for greater than or equals to 0. And in the case of p of x, this is p of x greater than or equals to 0. Second, and let us take third one, p of x is less than 0, that is x minus 3 upon x plus 2 is less than 0. So whereby the negative shaded negative part is obtained from negative 2 to 3. So x belongs to minus 2 to 3, we can take the solution. And for p of x less than or equals to 0, P of x is less than or equals to 0, that is x minus 3 upon x plus 2 is less than or equals to 0, which implies, so whenever it is less than or equals to 0, we can include some of the roots, but here negative 2 should not be included to define the function, and 3 can be included. So we can take the answer minus 2 to 3, or otherwise we can write x lies between minus 2 and including 3. So this is how the solution can be taken. Or here also x lies between minus 2 and 3. Here we can write x is less than x is less than negative 2, or x is greater than or equals to 3. Okay, now let's consider another example. Say p of x is equal to x plus 3 into x minus 2 upon x plus 5 into x minus 11. So which is of the form f of x by g of x. So zeros of f of x are minus 3 and plus 2. Since for x plus 3 is equal to 0, so we have x is equal to negative 3, and for x minus 2 is equal to 0, so we have x is equal to 2. So x is equal to minus 3 and x is equal to 2 are the zeros for f of x, and similarly zeros of g of x can be taken as negative 5 and 11. Now let us mark all these on number line. Mark this on number line in an order. So first comes negative 5, then negative 3, and then 2, and then 11. So from minus infinity to plus infinity the number line. So select the rightmost root, that's 11. So start taking the curve from this point, from positive side, from right to left, and at x is equal to 11, so we need to stop a while here and you need to check whether the power is odd or even. So for x minus 11 the power is 1, and of course we can observe that all the powers are odd, powers only 1. So everywhere we can change the sign from positive to negative or negative to positive. So let us change the sign from positive to negative. The curve will come to the negative field, and again at the point 2, so it changes from negative side to positive, and again from negative 3 it changes the curve from positive to negative, and again at negative 5 it changes from negative to positive. So this is what the curve, wavy curve is drawn, and then we can identify the solutions for this. Let's take first one, p of x that is greater than 0, which means that your x minus 3, sorry, x plus 3 into x minus 2 upon x plus 5 into x minus 11 is positive, for which x belongs to, we can easily tell the answer, positive in the region minus infinity to plus 1 here, and again from minus 3 to 2, and again from 11 to infinity. So we can combine them, minus infinity to minus 5 union, and again minus 3 to plus 2, again union, 11 to infinity. Since it's only greater than 0, everywhere all the points must to be excluded. So we call them as the critical points of the roots, those to be excluded. And coming to the next greater than or equals to 0, let's take the second case. P of x is greater than or equals to 0. Then in such a case, we can just include the numerator root points. So we can write here x belongs to minus infinity to minus 5 must be excluded because it is in the denominator. So open brackets union, and for negative 3 we can include negative 3 because it is in the numerator, so we can include this closed bracket, and 2 also can be included, so we can take close to union, and 11 is in the denominator, we should exclude it, so 11 comma infinity. So this is how the solution for greater than or equals to 0. And for the third case, the p of x is less than 0, we can find the negative solution here in the minus 5 to minus 3 and 2 to 11. So we can give the answer x belongs to minus 5 comma minus 3 union and again 2 to 11. And so the next case d1, p of x is greater than less than or equals to 0. So here we must include the roots for the numerator case, and for the denominator should be excluded. So let us write here x belongs to minus 5, it's an open, comma minus 3 is closed, union 2 is closed, and 11 is open, right? Let's see another example. Let's take fifth one. Let us consider the even powers. X minus 2 whole square. F of x is equal to x minus 2 whole square. So we can say very clearly x minus 2 whole square is always positive and it can be equal to 0 for x is equal to 2. So the x is equal to 2 is the 0 of the polynomial, is the 0 of f of x, and it is a double root, we say, since the power is even, it's a double root. Let's mark it on the number line, x is equal to 2, and start taking the curve from the rightmost point to from the upper side, positive side, positive, and again after reaching at the point 2 you need to check the power is odd or even. Since the power is even, so the curve will remain the same side, means in the positive side only, it will not enter to the, it will not intersect the line, so it will be remaining in the same side at the point 2. So we can give the answers now. For f of x is greater than 0, f of x is greater than 0 for every x belongs to minus infinity to, so we can write minus infinity and plus infinity, minus infinity comma 2 union again 2 to infinity, or we can also write this as all real numbers except at 2. Every real number we have taken, but 2 is excluded. So this is how we can give the answer. And for f of x is less than 0, for f of x is less than 0, we can give the answer. So for nowhere we can say that it is less than 0, so it's an empty set, belongs to, it's an empty. Nowhere we can find no value of x for which f of x minus 2 whole square is negative. And coming to the f of x is greater than or equals to 0, when it is greater than or equals to 0, we can say that it's a all real numbers, x belongs to r, minus infinity to plus infinity, x belongs to minus infinity to plus infinity, because we can include this one, minus infinity comma 2 closed, again union 2 to infinity, so which means that 2 is included in both, so we can write directly minus infinity comma plus infinity. And coming to the case like f of x is less than or equals to 0, in such a case less than or equal to 0, for less than there is no value of x which is negative, and for 0 there is a possibility for x is equal to 2, means we had only one solution, x is equal to 2, so we can give the answer singleton set. Okay, let's see another example. Let's take p of x is equal to x minus 3 whole power 3 into x plus 5 whole power 4 upon x into x plus 1 whole to the power 6. So which is of the form f of x by g of x. So clearly the zeros of f of x are plus 3 and negative 5, and zeros of g of x are 0 and negative 1. For x means we can write x minus 0, that is x is equal to 0, and x plus 1 we have negative 1. So let us mark this roots on the number line. So we have negative 5, negative 1, 0 and 3. So they are in order now. So now we need to take the curve from the rightmost root, that is 3, starting from the positive side. So just wait a while at 3. So for x minus 3 we had the power is odd. Odd power means it's a single root. So we can say its sign will changes from positive to negative. From positive to negative. And again at x is equal to 0. So the power is again 1. So it changes from negative to positive. And again from x plus 1 the power is even. Power is even, it remains in the same side, that is positive to positive only. And again at x is equal to negative 5 the power is even. If it is an even, so it remains in the same side. So this is how the curve will be drawn according to the rules. Okay, and now we can give the answers. For p of x, let us assume p of x is greater than 0. That is our x minus 3 whole power 3 into x plus 5 whole to the power of 4 divided by x into x plus 1 whole power 6 is positive for the values of x belongs to. So it is positive in the region minus infinity to almost like up to 0, but excluding those points here negative 5 and negative 1. So at these points your numerator will become 0, so which is inequality will not satisfy. So we must write here minus infinity comma minus 5 union. So x belongs to minus infinity comma minus 5 union, again minus 5 comma minus 1 union, and again minus 1 comma 0 union, again 3 to infinity. So all these points to be excluded, minus 5, minus 1, 0, and again here 3 also. So from 3 to infinity. And for p of x is greater than or equals to 0. For this we can give the answer as x belongs to, since is equal to 0, so we can include the points where the numerator roots. So we can write here minus infinity comma minus 5 can be included, and again minus 1 to be excluded. So we will write up to minus infinity comma minus 1 union, again minus 1 to 0, 0 must be excluded, so minus 1 to 0, again union. So 3 to infinity, 3 can be included, so 3 to infinity, 3 is included, so square bracket. So for p of x greater than or equals to 0, we can give the answer from minus infinity to minus 1 we can take directly because minus 5 is included, and again minus 1 to 0, then 3 to infinity, closed 3. And coming to the p of x less than 0, let us check that. P of x is negative. Negative is only in the region 0 to 3. So we can write here x belongs to 0 to 3 open interval. And the next case p of x is less than or equals to 0. So we can include the numerator points. So that is x belongs to 0 is in the denominator. So 0 is excluded and 3 can be included. So open 0 comma closed 3, right? So I hope you understood the wavy curve method with these examples. Thank you.